All right, today we're going over section 10.5, simplifying radical expressions. Okay, make sure you know and are comfortable with your perfect squares. Here's a list of them. So when you see, square root 25, it simplifies to 5, square root 81, which is 9, and so forth, square root 36, 6. The higher in math you go, these come up a lot, so it's nice to be comfortable with them. So a perfect square is a number whose square roots are whole numbers. So when you take the square root, it's going to be a whole number. Okay, today's goal, we're going to be simplifying roots of non-perfect squares. Okay, so like things like this, we got 28, 54, and 72. What do we do with those? And then also we're going to be simplifying cubed roots, not just square roots. Okay, so a square root is in simplest form, okay, when the square root contains no perfect square factors other than 1. So I briefly showed this yesterday in class, but square root of 8 is not considered simplified because we can break that down into prime factorization and pull out a perfect square. We're going to see, why that's not considered simplified. Square roots can't contain any fractions, so if I have something like 1/4 under a square root, that's not considered simplified. And we can't have square roots in the denominator. We saw this back with special right triangles when I had something like 2 divided by root 3. We're not going to deal with that rule today, but we've seen it before. We have to get that radical out of the denominator. Okay, so 2 properties that will allow us to simplify square roots today. We've got the product property of square roots, product meaning multiplying. Okay, so that means that if I have a product of 2 numbers under a square root, I can break them up into square root A times square root B. Okay, so meaning if I have square root, let's do 8 since we just talked about that. We can break this up into a product of square root 4 times 2, which 4 breaks down into 2 times 2, and I still have that other 2. So we call this a prime factorization. I've broken down 8 into a product of its primes where I can't go any further unless I did 2 times 1, which it's already prime. So this allows us to take out what's called a perfect square. 2 times 2, since they're in pairs, that's represented by square root of 4. You can take that out, and basically one of those numbers comes out as a whole number because the square root of 4 is 2. And what's left under there is one of those 2's. One of them couldn't come out. So this is actually considered simplified form. If you plugged this into your calculator and square root 8, they will result in the same decimal. All right. Now we have our quotient property of square roots. That just means that we can, if I have a quotient, something divided under a square root, I can break it up. Okay. So an example is if I have 1/4, I can break that up into the square root of 1 over square root of 4, which is 1 over 2. And it'll get a little more complicated as we go along, but we can apply that rule. Okay. So let's look at some other examples here. Simplifying square roots. Okay, our goal is to break this down into prime factorization. It does not matter what 2 numbers you start with. I'm just going to start with, and I like to put the square root over it so I don't forget. That's super important. I'm going to start with 2 times 14. I could start with 7 times 4. I think that's about it. 14 breaks down into 2 times 7, and I bring this other 2 down. So what I've done is I've broken down 28 as a product of 2 times 2 times 7. Since it's a square root, I can take out pairs. That represents square root of 4. So that comes out and becomes 2, leaving me with root 7 underneath. Okay, 54. I'm going to take this and write it as 9 times 6. 9 breaks down into 3 times 3. 6 breaks down into 2 times 3. I can't go any further. Those are all prime numbers. I see a pair of 3s. Whatever's left over, remember it's multiplication. We multiply those, so it's 3 root 6. And again, some of your calculators do this for you. Be sure you know how to do this on your own in case if we have a non-calculator section on a test. Okay, square root 72. You can start with lots of products. I'm going to start with 9 and 8. Break 9 up into 3 times 3. I can break 8 up into 4 times 2. 4 still breaks down, so I actually have 3 2s. Whoops. And 2 3s. So I could take out a 3 and a 2. Those get multiplied. So it's going to be 3 times 2 outside, which is 6, with 1 leftover square root 2. All right. So multiplying square roots. You can multiply, basically it's this product here going backwards. I can multiply the numbers together. Now, there's a hard way and an easy way. You don't want to take 7 times 42 and multiply it because that's going to be a large number. That is 294. So I'm on a video. So instead, keep it in prime factorizations. 42 will break down into 7 times 6. Or let me back up. I could actually, this might make more sense. Combine the 7 times 42 together like that. You're just going backwards of the product property. 42 breaks down into 7 times 6. Bringing that other 7 down. 6 breaks down 2 times 3. And we know we're done when we have all prime numbers. We have 1 pair of 7s that comes out, leaving me with root 6 underneath. All right, one more on this side. So again, don't multiply the 8 times 14. We're just going backwards of the product property. So we can do 8 times 14. Break down that 8 into 4 times 2. 14 as 7 times 2. The 4 can break down into 2 more 2s. And look for pairs. So we've got 2 pairs of 2s this time, which comes out to be 2 times 2, or 4, with 1 leftover 7. And I encourage you to check on your calculator if your calculator doesn't simplify. You can plug that in and plug this in, and they'll be the same decimal. All right, backside, guys. Okay, so dividing with square roots. If possible, simplify these radicals first. Otherwise, it's going to be a big mess. So I'll give you a hint on a lot of your homework. These will simplify as fractions. So meaning, I think 3 divides into both top and bottom. So basically, you're reducing the fraction into 14 over 9. Then our quotient property says I can break this up as the square root of 14 over the square root of 9. And of course, 14 doesn't simplify, but 9 does. That's a perfect square. Okay. Now, I didn't bother with 14 because it's just 7 times 2. And there's no pairs there. This can't simplify. Just because it's even doesn't mean it simplifies. There's no pairs of prime numbers that I can pull out. There's no perfect square. Okay, 80 and 18. This fraction can be simplified by dividing by 2. So I can simplify it to 40 over 9. Break it up into 40, square root 40 over square root 9. Again, I see that perfect square in the denominator. Okay, So that's one of our rules. We can't have a denominator that has a radical in it. Okay, but I also need to simplify that square root 40. So you'd have to do the whole process we did on the top page. That'd be 4 times 10, 2 times 2 times 2 times 5. We can take out a pair of 2's. So root 40 simplifies to 2 root 10. The denominator is a 3. Okay. Now on today's homework, you won't have any numbers that are not perfect squares here. So make sure you're looking for that. It's a whole nother lesson where we actually have to simplify that denominator when it's a square root. Okay, this last section, we're going to have variables here. So I kind of showed you a little bit yesterday in class, is we can basically treat this as 3 different problems. I'm going to do a prime factorization with the 75, the x to the 4th, and the y to the 5th. It just takes a little bit of time, but show all your work. So we got 3 times 25. So that's 3 times 5 times 5 for 75. And the x's, x to the 4th simply means I have 4 x's being multiplied. And the y to the 5th means I have y times y times y times y times y. Since it's a square root, I take out pairs. I can take out a 5. I can take out an x times an x, so that becomes x squared. I can take out a y times y, which is y squared. It helps to cross them out so you can see what's left, 3y. So just stay organized and show all those steps, okay? All right, let's do 147. 147 breaks down into 3 times 49, which is 3 times 7 times 7. Ugh. And then, doing a video, I'll be done in a sec. Then we have an x and 3 y's, 1, 2, 3, and 7 z's, 1, 2, 3, 4, 5, 6, 7. Hopefully I counted right. 1, 2, 3. Yep. Okay. And take out all your pairs. So we can take out a 7, a y, 1 z times another z times another z. That will be represented by z to the 3rd. What's left over? 3x, y, z. Okay. All right, last one, simplifying cubed roots. Okay, so we're no longer looking at square roots. Looking at cubed roots, they have the same properties. I don't know why they're written differently. It's the same thing. You can break up products or break up quotients. So we still want to do a factor tree here. This ends up being 7 times 49, which is 7 times 7 times 7. Now, since it's a cubed root, I'm looking for, obviously this is a perfect cube because I can take out triples now. That means the cubed root of 7 cubed, that's just 7. Okay, all of these come out. Okay, and that's just basically showing I have a perfect cube. Okay, that's because 7 to the 3rd equals 343. It's a perfect cube. Okay, if all the numbers come out, it's a whole number. There's nothing left under. Okay, unlike this one, I can break this down into 5 times, let's see, 3 times 45. 45 breaks down to 9 times 5. 9 is 3 times 3. Okay. So again, because I have this cubed root now, we're going to be taking out 3 groups of 3. Cubed root of 3 cubed basically comes out to a whole 3. I'm left with a cubed root of 5. Okay. All right, last one. Again, on cubed roots, we want to see if this simplifies first, right? And it does. They divide by 3, each of these guys. Jeez. Okay, get 15 over 8. And the quotient property says I can break these up. Okay, and if you recognize the bottom is a perfect cube, that's awesome. Otherwise, do your factor tree. And 8 is 2 times 2 times 2, so you know that's going to be a 2 down there. Okay, 15 is just 5 times 3, so there's no pairs. So we just leave it as the cubed root of 15. Okay. All right. And the last one has variables. Same idea, prime factorization for everything. 15 and 81, we can simplify the inside first. 15 and 81 simplifies to 5 over 27. I'm going to simplify it real quickly because this video is getting longer. And the denominator is x to the 3rd. We subtract those. Y to the 3rd, z to the 4th. So I just simplified these x's. Okay. That's all to the 1/3 or to the cube root. So now we're going to write out our prime factorization. So 5 times y times y times y times z times z times z times z. All over 27 ends up being 3 times 9 or 3 times 3 times 3. And then x times x times x. And then we're going to take out our triples. Okay, so we've got 3 y's, 3 z's becomes 1 z. What's left over in the top is 5 and z. The denominator is a perfect cube. We have a triple of 3's, which comes out, and a triple of x, which comes out to be 3x. Oh, and don't forget your little cubed root here. And we're done. Alrighty, guys. Oh, I did see that I forgot one up here. And again, just prime factorization, 36. I could just write this as 2 times 36, right? Same thing. 2 times 3 times 12. I can break 36 up into 3 times 12, different ways to do it. 3 breaks down into 3 times 4. Keep going until you get to primes. So 2 times 2. So hopefully I did this right because I'm going fast. Let's see. Yep. Okay. So the prime factorization, all that is 2 times 3 times 3 times 2 times 2. It's a cubed root. So once again, I'm looking for cubes. 3 together. That becomes 2 times the cubed root of 9. All right. Now I think I finished them all. Good luck on the homework, and I will see you guys in class tomorrow.